Let's get right into it. Welcome to This Explainer. I am so thrilled you're joining me today because, well, we are looking at a massive, fundamental shift happening right now in medical science. If you've been following the news over the last couple of years, you already know that single hormone therapies have completely reshaped how we look at obesity and type 2 diabetes. But the science, it isn't stopping there. Today, we're exploring the cutting-edge jump from those single hormone treatments to what researchers are calling multi-receptor metabolic engineering. Specifically, we are going to dive deep into a groundbreaking new molecule called Zenagamtide.
So I want to pose this question directly to you. What comes after the GLP-1 weight loss revolution? I mean, we're all familiar with the massive impact of drugs like Ozempic or Wegovy, right? They've been absolute game changers. But as incredible as they are, they primarily target just one pathway. Science is already moving to the next frontier, asking, hey, how can we safely target multiple metabolic pathways at the exact same time to unlock even better, more comprehensive results?
Okay, let's dive into this. Here is our roadmap for the explainer today. 1. The next incretin evolution. 2. How Zenagamtide works. 3. Subcutaneous trial results. 4. Oral trial results. 5. Safety and side effects. And finally, 6. The future of obesity treatment. Let's go. Section 1. The next incretin evolution. Moving beyond single hormone therapies.
Okay, so the therapeutic landscape for type 2 diabetes and obesity is rapidly evolving, and we are moving decisively beyond just single hormone therapies. To really understand this next step, we have to talk about amylin. This is a hormone that's co-secreted with insulin directly from your pancreatic beta cells right in response to eating food. But it doesn't just act in one place. It acts on receptors distributed all over across the brain, the pancreas, fat tissue, and the gastrointestinal tract. By doing this, it regulates your appetite, it delays how fast your stomach empties, and it decreases glucagon secretion. Ultimately, what it does is provide this highly coordinated, multi-site control of your body's energy balance. It is an incredibly powerful complementary pathway to GLP-1.
So, how have drug developers tried to harness this? Well, the old approach, and by old I literally mean what we've seen very recently, was a physical combination. Think of a drug like Cagrasima, which provided clinical proof of concept by physically mixing two separate drugs together, cagrelintide and semaglutide. You're basically carrying two separate keys for two different locks on a keyring. But the new approach, Zenagamtide, it completely changes the game. It is a single, unimolecular peptide. It's like a master key, one single, beautifully engineered molecule that seamlessly unlocks both the GLP-1 and the amylin pathways at the exact same time.
Which brings us right to Section 2, how Zenagamtide works, the master key molecule. This molecule, which was formerly known in early development as amycretin, is a next-generation unimolecular agonist. I absolutely love how researchers in The Lancet describe this. They note that Zenagamtide is engineered to synchronize peripheral glycemic control with central satiety signaling, thereby extending metabolic efficacy beyond the restrictions of single-pathway incretin therapies. Let that sink in for a second. By engaging these two complementary pathways within a single molecular scaffold, it entirely bypasses the natural limits of just targeting one hormone. It's physically coordinating the blood sugar control in your body with those crucial I'm full signals up in your brain.
All right, Section 3, Subcutaneous Trial Results. Let's look at the Phase 2 injectable data.
To test this in human patients, Pablo Mora and colleagues ran a 36-week, double-blind, dose-finding study for a once-weekly injectable version of the drug. Now, what's really interesting here is when we look at the patient demographics side by side. It's important to anchor ourselves in the real-world data. These were adults with suboptimally controlled type 2 diabetes who were already taking metformin. We're talking folks in their mid-50s with a baseline HbA1c hovering around 7.8 to 8.0% and a baseline BMI right in the 33 to 34 range. So these are patients who absolutely need serious metabolic intervention.
And wow, did the intervention deliver. Over 36 weeks, the injectable formulation showed this incredibly clear, dose-dependent drop in body weight. While the placebo group saw a, modest 2.1% drop, patients at the lowest dose of 0.4 milligrams saw a 4.3% drop. But when you look at the highest 40 milligram dose, patients experienced a massive 14.6% reduction in body weight. I mean, that is a highly significant drop.
Minus 14.6%. We need to remember the context of this figure. This dramatic drop happened in just 36 weeks. To put that into perspective, for a patient weighing 200 pounds, that's nearly 30 pounds lost in just about 8 months. And that's happening alongside massive improvements in their blood sugar control, with their HbA1c dropping by up to 1.7%.
Moving on to Section 4, Oral Trial Results. Let's check out the Phase 2 daily pill data.
Look, injections just aren't for everyone, right? Delivery flexibility is totally vital. So in a second trial, Moore and colleagues tested a once-daily pill formulation of Zenagamtide over that exact same 36-week period. And the results here? Also highly clinically meaningful, with HbA1c dropping by up to 1.5%, and the weight loss was incredibly impressive for a daily pill. At the 25 milligram dose, participants lost 10.3% of their body weight, and at the 50 milligram dose, they lost 9.0%. Now, the researchers did note that while there wasn't a perfectly linear dose-response relationship for weight loss across every single dose tested, the overall weight loss attained compared incredibly favorably to the other oral incretin therapies that are currently out there.
So the absolutely crucial point here is that body weight continued to decline throughout the entire 36-week treatment period without any evidence of a plateau. The curve was literally still pointing down when the trial ended. This strongly suggests that the full therapeutic potential of these higher doses might not have even been realized yet. Longer Phase 3 studies are going to be so critical to see just how far this durability actually goes.
Time for Section 5, Safety and Side Effects. The reality check. Of course, with any powerful medical intervention, we have to talk about tolerability. When we look at the safety profile, it was honestly generally consistent with what we already know from existing GLP-1 and amylin therapies. Let's walk through this carefully. Gastrointestinal adverse events, so think nausea or stomach upset, were the primary reason patients discontinued the treatment. There were also modest dose-dependent increases in heart rate, which again is something we've seen in previous incretin therapies, and importantly, the researchers noted that long-term surveillance is still needed to monitor for those uncommon but serious risks like pancreatitis or gallbladder disease. But we do have to address the elephant in the room regarding the highest subcutaneous dose of 40 milligrams, where 45% of participants actually discontinued treatment. Almost half. Sounds alarming, right? But context is everything here. The researchers explained that this high dropout rate at the upper doses was heavily influenced by the trial's incredibly rigid fixed-dose escalation design. Essentially, patients were forced to ramp up their dosage on a strict schedule. If they struggled with side effects, the trial rules didn't allow them to just step back down or re-escalate slowly, so they had no choice but to drop out. In real-world clinical practice, a doctor would just simply adjust the dose to manage those side effects.
Finally, Section 6, the future of obesity treatment, looking beyond glucose and weight.
The medical community is really starting to look far beyond just dropping pounds on a scale, and this brilliantly illustrates why. Early trial data for Zenagamtide shows massive, broader cardiometabolic potential. We saw improvements in systolic blood pressure. We saw lower high-sensitivity C-reactive protein, which, if you don't know, is a key marker for inflammation in the body. There's even preclinical evidence showing it reduces liver fat. I mean, this unimolecular peptide could potentially offer coordinated, multi-system protection for the heart, the kidneys, and the liver. Moving forward, a big focus is also going to be on finding ways to preserve lean muscle mass while all that fat drops off. As the Lancet commentary perfectly concludes, future development of combined GLP-1 and amylin receptor co-agonist therapies should focus on optimizing the quality and durability of metabolic benefits. See, it's no longer just about how fast someone can lose weight. It's about high-quality, long-lasting, complete metabolic health. It's about safety, tolerability, and true durability over the long haul. So I'm going to leave you with this final, provocative thought. As we watch Zenagamtide move into those much longer Phase 3 clinical trials, will these engineered, unimolecular, multi-receptor drugs prove to be the ultimate master key for our long-term cardiometabolic health? The data we have so far is incredibly compelling, and the next few years of research are going to be absolutely fascinating to watch unfold. Thank you so much for joining me to explore this breakthrough, and as always, keep learning.